Cheap LLMs can make AI agents cost more. The price of one call may be lower, but failures, retries, and human rework can push the total cost up. The useful comparison is not the cost of a call. It is the full cost of producing one result that passes your acceptance bar. In July 2026, OpenAI published a 5-step framework for managing AI investments. Its examples connect model capability with completion time and output volume, showing why unit price cannot represent value by itself. This episode turns those ideas into an accepted outcome cost sheet. It is a practical tool derived for this episode, not an official OpenAI template. This video is packed with practical value to help you get better at using AI. It is a longer one, so follow and save it for later. First, remove a common misconception. Token price is one cost input, not your total cost. OpenAI notes that the price per million tokens fell 97% from GPT-4 to GPT-5. Model calls really are becoming dramatically cheaper. But a unit price cannot tell you whether the task succeeds on the first attempt or whether the output meets your acceptance criteria. If a cheaper model repeatedly misses constraints, chooses the wrong tool, or produces unusable work, it creates retries, rollbacks, and human corrections. A higher-priced model can have a lower total cost when it finishes a complex task faster, uses fewer output tokens, and reduces expert intervention. Buying a model is not like buying a bag of identical tokens. You are buying capability, speed, and reliability for a specific job. Evaluate models on your own representative tasks and acceptance criteria, because public prices and general benchmarks cannot replace your real workflow. Chapter Recap. First, token price measures only one input. Second, failures, retries, and rework belong in the real cost. Third, compare accepted outcomes, not isolated calls. Second, change the unit of analysis from one model call to one accepted task outcome. Start with model and tool consumption, including input and output tokens, search, code execution, storage, and other usage-based charges. Then record the number of attempts. One successful run and 3 retries may use the same model, but they do not have the same cost. Next, measure completion rate. How many tasks independently meet the acceptance criteria you wrote before the run? Include latency and human review time. Waiting slows the workflow, while corrections consume scarce expert attention. Also include the impact of failure, such as a bad decision, a missed delivery window, a customer problem, or a compliance risk. A useful formula is, accepted outcome cost equals all run costs plus human review and rework costs, divided by the number of accepted outcomes. Chapter Recap. First, put every attempt and resource in the numerator. Second, count accepted outcomes with criteria defined in advance. Third, track completion rate, latency, and human intervention together. Third, choose models by task difficulty and risk instead of forcing every job into one tier. Use smaller and faster models for reversible tasks with clear rules and easy verification. Use frontier models when work is complex, ambiguous, high stakes, or depends on long tool chains and reliable boundary judgment. OpenAI's example says GPT-5.6 scores higher on the Artificial Analysis Coding Agent Index while using 54% fewer output tokens and taking 57% less time per task. That does not mean the strongest model is always cheapest. The question is whether more capability crosses this task's quality bar and removes enough failure and rework. Evaluate representative tasks first. Route stable, low-risk work to the cheaper model and escalate complex work to the stronger model. Re-evaluate the route when the task, tools, or quality bar changes. A benchmark is not a permanent routing decision. Chapter Recap. First, let smaller models handle work they can pass reliably. Second, use stronger capability for complex and high-risk work. Third, keep calibrating the route with real tasks. Fourth, put model selection inside a governance process instead of relying on personal preference. For each task type, define permitted models, data boundaries, tool permissions, and conditions for human takeover. Build an observable record of call cost, success rate, latency, review time, and failure types. Manage return across a portfolio of tasks. Some use cases are experiments, some are stable, and some should stop because they do not create enough value. Match funding to maturity. A prototype should prove the problem and value, a pilot should prove quality and workflow, and only a scaled system should receive scaled capacity. OpenAI recommends allocating capacity to proven demand rather than buying it early simply because budget is available. The purpose of governance is not to suppress use. It is to place stronger capability where it matters most and where results can be verified. Chapter Recap. First, define model permissions and takeover conditions in advance. Second, manage experiments, pilots, and scaled systems as a portfolio. Third, let capacity follow proven demand. Fifth, put the decision into an accepted outcome cost sheet. Column 1 is task and acceptance. Record the task type, risk level, and the exact bar for an accepted result. Column 2 is run cost. Record model usage, tools, attempts, and the direct cost of every run. Column 3 is delivery cost. Record completion rate, latency, human review, rework, and the impact of failure. Column 4 is routing. Record the default model, escalation rule, stop rule, and next review date. Do not fill the sheet with one average. Sample easy, typical, and difficult tasks, then compare smaller and stronger models in each group. Keep the cheaper model when its accepted outcome cost is lower. Escalate the route when failures and review work erase the unit price saving. You can screenshot this accepted outcome cost sheet now and use it in your own workflow. Chapter recap. First, define acceptance before recording cost. Second, compare models across different task difficulty. Third, route by accepted outcome cost. In short, a cheaper model is not automatically cheaper because the business needs accepted outcomes, not cheap calls. The source offers an investment and governance framework, not a fixed cost verdict for every model and task. Prices and capabilities will keep changing. For your next AI agent evaluation, track run cost, attempts, completion rate, latency, human review, and failure impact before choosing the route. Which AI agent task would you put into this cost sheet first? Share your use case in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.